ancient Australia, not all kangaroos were the gentle grazers we see today. Fossils reveal that some hunted meat, armed with sharp teeth and strong limbs. These carnivorous marsupials roamed the land millions of years ago, challenging our ideas about evolution in Australia. Let's uncover the truth about these forgotten apex marsupials. Fossil hunters in Australia often expect to find remains of giant herbivores or curious marsupials that munched leaves. That's why the discovery of meat-eating kangaroos caused such a stir. In the mid-20th century, paleontologists working in places like Riversley, a fossil-rich site in northwestern Queensland, stumbled across jawbones and skull fragments that did not match the usual kangaroo designs. Instead, these bones showed signs of sharp teeth and robust jaws, suited for a diet that included flesh. The first hints emerged when researchers uncovered partial jaws bearing pointed premolars, which is odd for a kangaroo. Typically, kangaroos have cheek teeth adapted for grinding vegetation, yet these fossils had elongated, serrated surfaces almost like little daggers. Early on, scientists refused to believe that such animals were truly carnivorous. They wondered if the teeth might be a weird adaptation for some tough plant or seed. But as more fossils appeared, the evidence for actual meat-eating habits grew harder to ignore. Over the following decades, two main forms stood out: Propleopus oscillans, often called the giant rat kangaroo, and a group known as Echaltodata. Each found at different layers in the geologic record represented marsupials living millions of years apart. Yet both sets of fossils revealed similar patterns: strong front teeth, stout skull shapes, and hints of a more aggressive way of living. They didn't fit the mold of a modern gray kangaroo bounding around on powerful hind legs while nibbling grasses. Instead, these animals seem to have used both front and hind limbs to move around, possibly stalking or ambushing small prey. In older studies, some paleontologists argued that the odd teeth might be for cracking nuts or insects. Others insisted that they indicated a real taste for meat, maybe even scavenging or attacking smaller vertebrates. The debate eventually leaned toward the carnivorous side, as more complete skulls and limb bones revealed sturdy muscles and tooth forms adapted for tearing, not just crushing. News outlets began calling them killer kangaroos or fanged kangaroos, capturing the public imagination. Riversley itself became a hotspot for strange fossils, from flesh-eating marsupials to monstrous flightless birds. These discoveries suggested that Australia's past was no quaint paradise of lazy wombats and docile kangaroos. Instead, competition and evolution led some kangaroos to take a more violent path. Thanks to years of careful excavation, we now know that at least a few marsupial species from ancient Australia were not content to eat leaves and grass. They took advantage of protein sources other than plants, reminding us how flexible and surprising evolution can be under the right pressures. Among these flesh-eating marsupials, Propleopus oscillans stands out. Often dubbed the giant rat kangaroo, it lived during the Pleistocene epoch and might have weighed around 40 kilograms. Its fossils show a compact but muscular build, with limbs strong enough to move on all fours. This posture is unusual for a kangaroo, as modern varieties hop on their hind legs. Propleopus oscillans seemed more like a bear or a fox in how it traveled, suggesting an endurance runner or a stealthy prowler. Dental remains are the biggest clue to its varied diet. While many kangaroos have flat molars for grinding, Propleopus had sharper, more pointed teeth at certain positions, indicating it could slice through tough material, possibly meat. Some scientists propose it was omnivorous, eating fruit, seeds, mushrooms, and small animals. Others argue that its teeth prove a strong taste for flesh, potentially making it a predator of reptiles, birds, or smaller mammals. Either way, it broke the typical plant grazer mold. Its nose was robust, and the jaw muscles attached to a sturdy skull. This setup allowed it to bite harder than a normal kangaroo, though perhaps not with the crushing power of a true carnivore like a big cat. Still, the presence of forward-pointing canines or premolars indicates a capacity for tearing or gripping prey. Paleontologists suspect this marsupial might have scavenged if an easy meal presented itself, especially if large carnivores like Thylacoleo were around, leaving partial carcasses behind. Propleopus's limb structure also intrigues scientists. Fossils reveal forelimbs with enough flexibility and muscle attachments to suggest active use in handling food or climbing rough terrain. This might have let it tackle struggling prey or root around for high-protein morsels. In areas with uncertain weather or limited plant growth, a little extra protein could mean the difference between life and death. That advantage might have driven the evolution of meat-eating features in an otherwise docile lineage. Despite these predator-like traits, Propleopus did not transform into a giant saber-tooth. It likely remained an opportunistic omnivore, blending scavenging with small hunts. We can imagine it rummaging through forest floors or near riverbanks, using its nose to sniff out carrion or nesting animals. If confronted, it could defend itself with a strong bite and sturdy claws. Eventually, like so many of Australia's unique megafauna, Propleopus oscillans disappeared, probably due to climate changes, shifting habitats, or human arrival. If Propleopus oscillans was a mild-mannered omnivore, Echaltidata might have gone further down the road of carnivory. Known from deposits in Queensland's Riversley sites, it lived millions of years before Propleopus, during the late Oligocene to Miocene epochs. Researchers often call it the killer kangaroo, because its fossils suggest it is truly predatory behavior. Where Propleopus had pointed teeth, Echaltidata had elongated, serrated ones, perfect for cutting or stabbing prey. This sets it apart from almost any other known kangaroo. Echaltidata's jawbones reveal a specialized third premolar shaped like a small buzzsaw. In typical grazing kangaroos, that tooth would be broad and ridged for grinding plants. But in Echaltidata, it's a blade-like weapon. Paleontologists argue that such a tooth evolved for slicing flesh, not just tough seeds or insect shells. Combined with the presence of robust forelimbs, Echaltidata could have pinned down struggling animals and inflicted deep wounds. It's a shocking idea. A kangaroo that leaps or runs and then grapples with a living target. Some reconstructions show Echaltidata about the size of a dog, possibly 10 to 15 kilograms or a bit more. That's not huge, but enough to tackle small or medium prey. It might have ambushed lizards, birds, or lesser mammals, sinking its toothy grin into them with swift bites. The wide arch of its jaws gave it a strong bite force for its size, letting it kill or disable quickly. These hunts might have occurred along riverbanks, forest edges, or scrubland, wherever smaller creatures foraged. The limb structure points to a partial hopping ability, but it could also move on all fours. That means it might have combined bursts of hopping speed with a stable quadrupedal stance for stealth or grappling. Some scientists even envision it using a half-upright posture to wrestle prey, though that remains speculative. Still, the evidence of strong claws or stout digits further supports a predatory lifestyle. If an animal tried to wriggle free, those forelimbs could cling tight. Critics once thought the bizarre teeth were for cracking hard seeds or nuts. However, the serrated edges and wear patterns line up more with cutting meat. Studies of tooth microwear also show patterns consistent with slicing softer tissues. The animal's skull shape, particularly the way its cheekbones flare, suggests big jaw muscles for biting. Over time, the image of Echaltidata as a plant eater faded. Now it's remembered as an odd marsupial that truly embraced carnivory. Both Propleopus oscillans and Echaltidata shared traits that set them apart from the typical kangaroo image. Their bodies were more flexible, their jaws more heavily armed, and their forelimbs stronger than what you'd see in a modern wallaby or gray kangaroo. To appreciate these carnivorous marsupials, it helps to break down a few key physical adaptations. First, their teeth. Kangaroos usually have broad molars for grinding leaves and stems, but in these meat-eating lineages, certain teeth took on a conical or blade-like shape. Propleopus's teeth were pointed enough to shear protein-rich foods, while Echaltidata's distinctive serrated premolar added serious cutting power. Dental analysis shows that the enamel thickness and cusp arrangement are suited to biting into tougher substances than simple grasses. Next, the skull. Both genera had deeper, sturdier skulls than the average kangaroo. Big attachment points for jaw muscles indicate a stronger bite. The arches over the cheek area flared outward, leaving space for muscle that could clamp down on prey. In some specimens, the snout region is shorter and more compact, a trait often seen in predators seeking to maximize bite force in a quick strike. Forelimbs also played a major role. Marsupials like the modern musky rat kangaroo have somewhat flexible forelegs, but in Propleopus, and especially Echaltidata, the arms appear even more robust. Fossil evidence shows thick bones and strong claws, or at least tough nails, that might have been used to grasp or hold prey. This feature contrasts sharply with typical kangaroos, which rely on hind limbs for locomotion and keep forelimbs mostly for balance. Then there's movement. Hopping is the hallmark of living kangaroos, yet these carnivorous forms could shift between short hops and four-footed movement. Paleontologists suspect that such variety lets them chase or ambush creatures in dense undergrowth or near the water's edge. Skeletons reveal joints that had a slightly greater range of motion, letting them pivot or lunge in ways not typical of modern kangaroos. Finally, overall size. Though not as huge as apex predators like saber-toothed cats, some forms were big enough to challenge small to medium prey. Propleopus reached around 40 kilograms, and Echaltidata, though smaller in some respects, boasted a lethal set of tools for hunting. Both were far heavier than the usual potaroos or rat kangaroos. We can imagine them using ambush strategies, lying in wait behind rocks or shrubs, then leaping out to deliver a swift bite. Australia's prehistoric stage was filled with odd creatures: giant flightless birds, big reptiles, and specialized mammals. Into this mix entered the carnivorous kangaroos. Their presence changed the delicate balance between predators and prey. Instead of large dog-like marsupials or reptilian hunters ruling every corner, these bounding or scampering kangaroos stepped in to claim a slice of the food web. Imagine a forest or scrubland with small mammals, lizards, and ground-dwelling birds. Propleopus might lurk around fallen logs, sniffing for carrion or catching an unguarded nest of chicks. If scuffles broke out over a carcass, it could hold its own with a strong bite. Echaltidata, living in an earlier time, might stand near a creek bed, waiting for something unsuspecting to come close before pouncing with serrated teeth. This dynamic raised the stakes for other mid-sized predators. They had new competition for fresh kills. Some carnivorous marsupials like Thylacoleo, the so-called marsupial lion, might still have been bigger threats, but these killer kangaroos carved out their niche by focusing on smaller prey or opportunistic feeding. Smaller animals, from rodents to juvenile reptiles, had to watch for a new kind of danger. Instead of just gliding lizards or snake-like creatures, they faced a furry, possibly hopping pursuer with strong limbs. Ancient birds, like big flightless species, might also have fallen victim if they stumbled into these kangaroos' domain. For large herbivores, the threat may have been less direct, since these kangaroos likely aimed for targets they could overpower, but that didn't stop them from scavenging on larger carcasses or attacking vulnerable offspring. In times of scarcity, these predators might strike at anything, intensifying the struggle for survival. Over millennia, some animals might have adapted by hiding better or breeding faster. Competition among carnivores also played out. If two apex hunters arrived at the same meal, aggression or a show of force might decide who got to eat. Echaltidata's build suggests it could handle itself in close quarters. The possibility of short but intense fights could shape how each predator roamed and patrolled territory. Over time, each species might have avoided confrontation by specializing in certain prey or habitats. The rise of these meat-eating kangaroos had real consequences for the ecosystems they inhabited. By consuming small vertebrates, scavenging on larger carcasses, and battling other mid-tier predators, they helped structure who thrived and who vanished. Their sharp teeth and strong jaws likely kept certain rodent-like mammals or ground birds in check, influencing how those prey animals spread or evolved. Some local species might have shrunk in size or adopted nocturnal habits to dodge the new threat. Yet their success was tied to a changing climate. Over millions of years, Australia's environment dried out, and forests receded. Rivers shifted, wetlands vanished, and open savannas expanded. For some time, these conditions still allowed carnivorous kangaroos to find prey. But as resources fluctuated, the competition from other predators, like larger marsupials or even big reptiles, became intense. Hard times can lead to more conflict or a narrower diet, straining specialized hunters. Another factor was the arrival of new animals through shifting land connections or evolving lineages. Certain marsupial predators that used better stealth or had a stronger bite might have replaced these kangaroo-like hunters. The fossil record suggests a turnover in predator guilds, where older forms faded as more advanced species gained ground. In addition, changes in vegetation could reduce prey populations, making it harder for these hunters to find regular meals. Propleopus oscillans managed to persist into the Pleistocene, but eventually disappeared. Why? Possibly climate chaos or the arrival of humans played a role in its downfall, just as many Australian megafauna died out after people reached the continent. If these kangaroos scrounged for leftover kills, losing big carcass producers also spelled trouble. Smaller, lighter predators might have adapted more easily, leaving heavy-boned carnivorous kangaroos behind. For Echaltidata and related species, extinction likely came earlier. The fossil record shows they inhabited a world full of exotic mammals and giant birds. When that world changed, the specialized nature of these predators might have hampered them. If their main prey vanished or the environment demanded new survival tricks, they had few options left. Their loss altered the balance of power. Without these tough marsupials, other omnivores or carnivores rose to fill the gap. Some smaller animals might have flourished without fear of a hopping or galloping ambush. Over time, the legend of flesh-eating kangaroos faded into ancient dust, leaving only bones for curious paleontologists to piece together. By the time modern humans arrived, only docile plant-eating kangaroos remained. The memory of their fierce cousins had long vanished, overshadowed by gentler grazers that define kangaroos for us today. These carnivorous kangaroos left more than bones behind. They reshaped how we understand evolution in Australia's marsupials. Once, the idea of a meat-eating kangaroo sounded absurd. Yet, here we have real fossil proof of marsupials that broke the mold. This discovery challenges the belief that all kangaroos took a single path toward grazing. They could diversify into many shapes and diets when the environment favored it. Such findings also reveal Australia as a hotbed for experimentation in the mammal world. Isolated from other continents by oceans, the island continent allowed its marsupials to evolve in surprising ways. Some climbed trees, others hopped across grasslands, and a few decided to grow fangs. This mosaic of lifestyles underscores the adaptive power of evolution under unique conditions. No major placental predators roamed these lands, so marsupials filled multiple niches, including apex hunters. In cultural terms, the notion of a carnivorous kangaroo sparks fascination. Indigenous Australian stories sometimes refer to fearsome creatures lurking in the bush, though direct links to Echaltidata or Propleopus are speculative. Still, these ancient marsupials might have influenced local legends about dangerous beings in the wilderness. Modern Australians often see kangaroos as mild icons of the outback. Learning that some ancestors had sharp teeth and predatory habits can shift that perspective, reminding us that nature's creativity knows few bounds. Studying these lost marsupials also gives us insight into how climate change and human activity can reshape fauna. The eventual extinction of these fierce kangaroos might hold lessons about adaptation and specialization. If an animal invests too heavily in one feeding style, a sudden shift in prey availability or habitat can spell doom. These past events resonate today as modern ecosystems face shifting temperatures, altered rainfall, and human impacts. We see that success in the short term doesn't guarantee long-term survival. These discoveries might spark new interest in exploring lesser-known fossil sites. Riverslea, once overshadowed by more famous dinosaur locales, turned into a treasure trove of odd Aussie mammals. Who knows what else remains hidden in the ancient layers? Each new dig or fresh analysis might unearth another strange branch of the kangaroo family tree, or reveal deeper insights into how life thrived in prehistoric Australia. In that sense, the legacy of Echaltidata and Propleopus oscillans is ongoing. Each generation of researchers revisits these bones and asks fresh questions, broadening our view of what's possible in the marsupial world. Our image of the cute, bouncing kangaroo changes forever when we learn about Echaltidata and Propleopus oscillans, marsupials that hunted meat with sharp teeth and strong jaws. These fossils remind us that Australia's past was full of evolutionary surprises. What's your take on these killer kangaroos? Let us know below, and make sure to catch our next video, shown on screen.